You may have heard about the recent discovery of exoplanets as observatories like the James Webb observe the Milky Way. We discovered the first planet outside of our solar system in 1992, yet in the comparatively small region of space that is only a few thousand light years across that is home to us, over 5,500 planets have since been confirmed. With the Milky Way's diameter of 105,700 light-years, the rest of our galaxy holds up the tantalizing prospect of billions or even trillions more. There are probably one or more planets around each star on average. It makes sense that we would want to focus on planet habitability and Goldilocks zones, given the abundance of exoplanets out there just waiting to be discovered. After all, humanity aims to colonize the stars, and theoretically speaking, Earth 2.0 is waiting for us somewhere out there. You may have perhaps already seen the term Earth 2.0 used in the headlines of publications or movies, which assert that a new planet has been found that is perfect for human habitation, but don't take the publicity seriously. Scientifically speaking, every planet we have discovered thus far has been terrible. You'll agree with me when I say that moving to any of them would be the last thing any rational person would want to do. Come along with me as I show you the grand real estate tour of the possible Earth 2.0s that have been found thus far, and discuss why this is not the ideal moment to climb the planetary property ladder. Just like when purchasing a home, it's a good idea to start by deciding what aspects of Earth 2.0 are non-negotiable. A portion of this is quite easy to think about, as in the case of temperature. You should be in an area with a pleasant, moderate climate, somewhere that is neither too hot nor too warm. Since the temperature decreases with increasing distance from the sun, each planetary system has a sweet spot where a planet's temperature is probably just right, that is, neither too hot nor too cold. Generally speaking, a planet may have a temperature that is ideal for humans to settle down on if it is the proper distance from a star. Naturally, there's no certainty here. As Venus, a planet in this zone is the hottest planet in our solar system, despite being closer to the sun than Mercury. Its strangling atmosphere prevents Venus from being a perfect planet in principle. Therefore, the atmosphere is also important in all of this. You should search for an atmosphere on Earth 2.0 as well, preferably one that contains oxygen and water vapor and is free from any toxins that could harm humans. At the very least, an atmosphere should be able to trap heat and provide some protection from space radiation. But occasionally, having nearby neighbors is just non-negotiable. Let us now examine the primary cause of the exoplanet's failure in the galaxy, which is their nearby stars. In comparison to some of the other alternatives available, our star, a G-type yellow dwarf, burns relatively quickly and has a limited lifespan. The typical lifespan of a star like our Sun is 10 billion years, after which their core collapses and they turn into red giants. It has been helpful for the life that eventually grew here since it is stable. But only 10% of the stars in the Milky Way are yellow dwarfs, making them extremely uncommon. Red dwarfs, which comprise 75% of the stars in our galaxy and have a life expectancy of approximately 14 trillion years, longer than the universe has existed, are far more prevalent. Red dwarfs also have a number of disadvantages for the planets that orbit them. In comparison to their yellow cousins, red dwarfs have a significantly closer Goldilocks zone. An Earth 2.0 would want to be much closer to its red dwarf in order to make up for their lower burning brightness, which ranges from 10% to a pitiful 0.0125% of our suns. Alternatively, you could choose to live in a world enveloped in perpetual darkness, which sounds chilly and depressing to me and would make growing plants somewhat difficult. If red dwarfs didn't have their instability, which is their second trait that makes them particularly disagreeable neighbors, this wouldn't be a problem in and of itself. Our space weather is primarily produced by our sun. Solar winds, flares, and coronal mass ejections are frequently released by it. But this pales in comparison to the volume of space weather produced by red dwarfs. red dwarf flares can have a power 100 to 1,000 times greater than that of our suns. Red dwarfs emit plasma and radiation bursts on a regular basis that are so strong and dangerous that they can evaporate an atmosphere or even boil liquid water on planets in the habitable zone. Furthermore, the likelihood of life having enough time to emerge before being exposed to a lethal dosage of X-rays is quite low in our red dwarf system, due to how much closer planets are to their star. A lot of sunscreen will probably be necessary if you want to live on a planet around a red dwarf. Numerous exoplanets are eliminated by this, including the astronomer favorite Kepler 186f, which some scientists have thought might be habitable. Under a deep subterranean bunker on such a planet, one could survive for a while under quite unpleasant circumstances, but it would not be a pleasant experience. However, the propensity of planets orbiting red dwarfs to be tidally locked poses an additional issue, especially at times between severe solar weather occurrences. When a planet is tidally locked, its orbit is such that its same side is constantly facing the star. There is no rotation between day and night. Instead, one side of the planet experiences constant heat, while the other is always in shadow. Observe Mercury, whose days last 176 Earth days, or 2 Mercurian years, to see how tidally locked planets near the Sun tend to become due to gravitational pull. A lack of rotation might make most of the Earth uninhabitable. Throughout the day, you would either be faced with frigid ice or blazing heat that would make you feel like you were in the desert. Finding liquid water could be challenging, even if humans attempted to survive in the thin layer of twilight that would encircle a planet that is tidally locked. Every drop of moisture in the atmosphere that made its way to Earth's night side would be trapped there and turned into ice. Generally, the planet would be extremely dry, with no rain even during the twilight hours. Furthermore, a tidally locked planet is probably not going to have a magnetic field with much strength. The Earth's rotational momentum imparted to rising and falling liquid metal in its core is known as the Coriolis effect, and it is believed to have an impact on the dynamo effect that drives the planet's magnetic field. A magnetic field like this would unavoidably be weaker without this rotation. Unfortunately, this means that worlds like Proxima Centauri b, our nearest exoplanet, are not eligible. All things considered, Proxima Centauri b is an intriguing contender because it is one of the worlds that is simplest for humans to reach, just 4.2 light-years away. Conveniently, it is believed to be a rocky, Earth-like planet. Living on a gas giant would probably be difficult for somebody who enjoys having a solid ground beneath them. Most intriguingly, its mass and radius are relatively identical to Earth's, indicating that its gravitational pull is comparable. What makes this significant? Comparing it to Kepler 452b, another contender for Earth 2.0, will help. The planet dubbed the closest twin to Earth by a NASA scientist, and the first planet to ever be addressed by such name. There are many good things about Kepler 452b. It is at a similar orbital distance to us around a yellow dwarf. Accordingly, it is in the region that allows liquid water to exist on the surface, or the Goldilocks zone. But it's a super-Earth nonetheless. This indicates that its mass and radius together give it a gravity that is roughly twice that of Earth. How much is too much in the case of gravity? According to some researchers, the number is 4 times Earth's gravity, which is roughly the maximum amount of time a human might survive. But it might get difficult even to live in a gravity that is only twice that of Earth. Imagine lying down, and then picture someone else lying down on top of you, bearing all of their weight on you, to help you visualize this property, or at least get a general idea of it. Every night is yours, including this one, fighting for each and every breath. As dawn breaks, you have to hoist that extra person up and put them on your back so you can take them everywhere you go. Everywhere. And watch out not to tumble, because it's much simpler to shatter a bone when anything falls. Stairfall falls are probably fatal rather than painful nowadays. Everyone needs to carry out this action. The the elderly, the ill, baby steps, stumbling on their first attempt at walking. Don't forget to leave a like and subscribe so we can see further beyond the void. Thank you. It's simple to understand how draining living under double gravity could ultimately be. If you're an athlete or a bodybuilder, you should be fine. However, it would be a slow and agonizing experience for the majority of people on Earth. Your heart is racing to pump blood throughout your body, giving you the impression that you are running even though you're not. And suppose you'd like the gravity to triple. On top of that, add someone else. Additionally, things don't get much better in the other direction. Indeed, once that weight is removed, everything becomes considerably simpler. But as astronauts who have just spent a few months on the International Space Station can attest, there are a number of health hazards associated with living in low gravity. Your bones grow brittle as a result of the calcium eroding from them over time. Your musculature atrophy, heart problems arise, your immune system deteriorates. The bottom line is that even with regular exercising, your long-term chances of surviving in a low-gravity environment are poor. This fact is posing a challenge to NASA scientists as they work to establish human outposts on the Moon or Mars, where astronauts may spend a few years living. Over millions of years, humans have evolved to survive on our planet. Here, things are extremely accustomed to us. Because we haven't adapted to these kind of environments, we just aren't equipped to be there. It's an indication of how successfully we've adapted to our birth environment in certain ways, but it also presents a significant challenge to our desire to live elsewhere in the future. The search for Earth 2.0 continues as a result. As previously stated, the Milky Way galaxy is probably home to billions of unknown planets. The likelihood that there is at least one out there that satisfies our requirements for gravity, temperature, radiation protection, and the presence of water and atmosphere is so great that it's almost a given. It is more difficult to actually identify one that satisfies their requirements, especially as most planets are still invisible to even the most powerful telescopes, save for a fleeting instant when they pass in front of a useful star and block off its light. You should proceed cautiously if someone claims to have discovered Earth 2.0. Till we manage to travel across the chasm of space and visit a planet, we will never truly know if it is habitable for humans. Naturally, it's all kind of a moot point until we figure out how to accomplish that. I thank you for watching. Make sure to leave a like and subscribe, and I hope to see you again soon.